Hello and welcome to Fireside Math Chats with Mr. Bacallier. I know a lot of you are concerned about what's going to happen now that we're not in school. You're wondering, what's going to happen to me? What's going to happen to my math skills? How will I continue to learn? I'm here to support you in your time of need and let you know that everything is going to be okay. So, what we're going to do right now is we're going to talk about a pretty common problem that you'll see on AP tests. And this is problem number 3 from the 2014 test. This is a non-calculator problem, which you'll see is included as a link in the comment section down below. But if we look at problem number 13, it talks about this graph. And it says that this is a graph of f. The graph of f is made up of a continuous set of line segments that goes from -5, 2 to -3, 0, up to 0, 4, and then down to 4, -4. And then they also tell us that the function g of x is equal to the integral from -3 to x of f of t. Now the first thing that this question asks us to do is to be able to find g of 3. Now, if we're trying to find g of 3, we know that g of 3 is going to equal the integral from -3 to x becomes 3 of f of t with respect to t. Which means that all that we need to worry about is what is the space that is underneath this curve from -3 to 3. We note that we are moving from a negative value to a positive value, so we're moving to the right. So everything is pretty straightforward there. All we have to do is look at our graph. So this graph is made up of a series of triangles. As we go from -3 up to +2, we would have a triangle with a base of 5, a height of 4. So if we take 1/2 of 5 times 4, this would have an area of 10. Then after that, we have to find the area of this little space. And this little space right here is going underneath the x-axis, which means that this value is going to be negative. So this has a base of 1, a height of 2 in the negative direction. So 1/2 of 1 times 2 would give us an area of -1. What that means in terms of our problem is that our integral is going to be made up of the area 10 plus -1, which means that our answer to part A is going to be equal to 9. The second question that we're asked is on what open intervals contained in -5 to 4 is the graph of g both increasing and concave down. Now, one thing that's really important in this situation is to understand that this is talking about g. Remember that our graph is f. So if g is going to be increasing, let's think about what that means. G increasing means that g's slope would be positive. So for g's slope to be positive, we would need the derivative of g to be positive. And let's remember what we're dealing with here. G is equal to the integral from -3 to x of f of t dt. So if we want to know what the derivative of this thing is, then we're going to take the derivative of the integral. And when we end up going through our fundamental theorem of calculus, we understand that this is going to become just f of x. So what this question right here is asking is, when is our function value positive? So let's look back at our graph. Our function value is positive from -5 to 2. Or, sorry, to -2. That should be a negative right there. Not sure where I put my chalk. Our function value is positive from -2, or sorry, oh no, that should be it. Oh, never mind. So that's the point -5 too. I was getting confused. Our function value is positive from -5 to -3. That's what I was looking for. From -3 up to +2, and then after that it's negative the whole time, so we don't really care about that space. So if we're wondering when our original function f of x is going to be positive, I have a really good system here for changing my board. G is going to be increasing when f is positive, and that happens in the space from -5 to -3, and from -3 up to 2. And the second thing they ask about is when G is going to be concave down. Now, if we are talking about concavity, remember that we're going to be concave down if the second derivative is negative. Well, the second derivative is just the derivative of the first derivative, the slope of the first derivative. So we're interested in when the slope of f of x is negative. So the slope of f of x is going to be negative from -5 to -3, and from 0 all the way to 4. So let's go back to what our original question was, which is, when is G both increasing and concave down? That means that we need to meet both of these requirements. So the space that we're going to meet both of these requirements is definitely between -5 and -3. And since this goes from -3 to 2, and this goes from 0 to 4, we're going to have an overlap from 0 to 2. So remembering that they asked us for an open interval where this is occurring, our answer to B would be from -5 to -3, and from 0 to 2. The third question that we are asked in this problem, let's just turn this into an x and this into an x, is about a new function, function h. And they say that h of x is equal to g of x divided by 5x. And they want us to find h prime of 3. Well, I'm taking the derivative of h, which means that I'm going to need to be using my quotient rule. So I'm going to take low d high minus high d low, which is just going to be 5, divided by low squared, which is going to be 25x to the second power, because I have to square the entire thing 5x. So all of these are going to be evaluated at 3. So I have 5 times 3, which is 15, multiplied by g prime of 3 minus g of 3 times 5 divided by 25 multiplied by 9, because that's going to be 3 squared, is going to be 225. So now I have to think back to, what do these things mean? G of 3 that was my integral from -3 to 3, which we actually figured out in part A of this problem. We figured out that g of 3 was going to be equal to the value 9, which means that this thing right here is a 9. G prime of 3, remember the derivative of g was just the function f. So really we're just asking, what's f of 3? If we go back to our graph very fluidly and sleekly, maybe I should put some wheels on it. F of 3 is the value -2. At 3, our function value, because this is the graph of f, is -2. So we can take this thing and replace it with a -2. So we're going to have 15 multiplied by -2 minus 9 multiplied by 5 divided by 225. Remember, if you're working on the AP test, this is considered a valid answer. You don't have to go through and simplify this at all. We could, this would be -30 minus 45, which is going to become -75 over 225, which you could then reduce and it becomes -1/3. But you don't have to do any of that. This is an acceptable answer. So we're done with part C. Last part asks us about yet a new function. It says that p is defined by p of x equals f of x squared minus x. So let's erase all this business again. So p of x is equal to f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals -1. So this is a tangent line question. And for any tangent line, for any line, frankly, we need two things. We need to know a point, and we need to know the slope. Well, we want to find the tangent line when x equals -1. So we're going to plug in -1 into our function p. Well, -1 coming in here means that we're going to be taking f of -1 squared minus -1. Well, this is going to be 1 plus 1, which is 2, so we're finding f of 2. If we look back at our graph that we were looking at before, f of 2 was equal to 0, because that was our point on this graph. And so that value is just 0. So there's our point. Our point is at -1, 0. Then we need to know what the slope is. Well, the slope is going to be based off of the derivative of this. Be very careful. This requires the chain rule. To take the derivative of this, we're going to need to take the derivative of the outside acting on the inside, multiplied by the derivative of the inside, which is going to become 2x minus 1. And this is all happening at -1. So the first thing I would do is take this -1 and plug it into this thing so I can see what numbers I'm dealing with. So I'm going to take f prime of -1 squared minus -1 is going to be, that's going to be my 2 value again, multiplied by 2 times -1 minus 1. And 2 times -1 minus 1 is going to be -3. So I'm taking the slope at 2 multiplied by -3. my slope at 2 is the slope of this line f at 2, which is equal to -2. So I have a slope of -2 multiplied by -3, which equals 6. So I now know what my slope is. I now know what my point is. So if I put this in point slope form, y minus my y value, which is 0, would equal my slope, which is 6, multiplied by x minus my x value, which means that I'm going to end up adding on 1. That gives me my equation of my tangent line, which is the very last thing that this problem was asking about. At this point, we have finished question number 3 from the 2014 AP test. I hope that it was invigorating for you, that you were filled with joy and happiness, and that you're just feeling good about math right now. This has been Fireside Chats about mathematics with Mr. Bacallier. I hope that you all have a wonderful day, and I'll see you all soon.